Hello everyone. Today we are going to learn about ARIMA, a powerful tool for forecasting time series data. Let's say you're running a store and you want to predict the sales in the coming days using the past data. That's where we can use ARIMA to do that. Stay tuned. In this video, we see sales graph and how it is synthesized. What are the constraints of the sales graph? And visualize ARIMA, which is autoregressive, integral, and moving average parts, and get a sneak peek on how to predict the future value. Okay, so we will use the example of monthly sales data from, let's say, an imaginary store, and it's synthesized data to illustrate ARIMA, how ARIMA works. Sales values is used on y-axis and time is an x-axis. The idea is to find what will be the sales after 100, 120, etc. This is the code used to generate the sales data. Don't worry much if you don't understand the core. The sales data has three parts. First, the trend, the straight line going up here. Second one, seasonality, a sinusoidal wave up here. And the last part is noise. If you add all this, you will get the sales data. In real life, of course, the trend, the seasonality, and the noise may not be this simple. Well, ARIMA helps us to get the future value. Of course, it has three parts mainly: the autoregressive part, integrated part, and moving average part. The autoregressive parts predicts the variable using its own past values. The integrated part uses the differencing to make the series stationary, and the moving average part uses the past forecast errors for prediction. We will visualize all these three here. First starts with autoregressive part of ARIMA. The AR part uses past values to predict future values, as we saw before. And let's say in this example, we are choosing 5 different past values to predict the future value yt. And how this is done using a mathematical expression, let's see. Well, yt can be predicted using this mathematical expression given here. And we can see it has taken p past values to predict value at time t. And we have to predict phi1, phi2, phi-p using an algorithm. Its parameters to be estimated. And there is an error term here, and there is also a constant term c. This gives us the future value yt. This is the autoregressive part. The next part, which is the integrated part, to understand this, we have taken a small part of sales data here on the blue color you can see over there, and we from this sales data we are getting the difference graph. We are differencing past value to get this graph here. The main idea here is to make sure that the difference graph is stationary, and we can observe that the difference graph moves around a constant mean, which means it is stationary. And this is really important for building an effective ARIMA model. The last part here, it is the moving average part. We can see here in this example, we have taken randomly 5 different points, and then we are taking the average of those 5 different points. And if you connect all these averages like all across the sales, you'll get the moving average graph this way. And here we have used the window of 5 in this example. Well, that's the three parts. We have seen the autoregressive part, the integrated part, and the moving average part of ARIMA. And using these three values we call PDQ, where P is the order of the autoregressive part. Here we are using 5, and D is the order of differencing. Here it is 1, and Q is the order of moving average part. Here it is 0. This is the best parameters 510, and this can be found using AIC and BICs. So this AIC and BIC I will discuss in the next video. If you like to know, please comment that. Well, once we have these best parameters, and we can use that to predict the ARIMA, predict the graph using the ARIMA, and we can also get the forecast. Voila, that's the thing we are looking for. We wanted to see the forecasted values, and now we know what are the sales in the coming days. Well, share the content if you like, and please comment below if you want to know how to find the best parameters. Thank you for watching.